It's very.
Yeah, thank you, Professor Reddy, for this opportunity. And I'm extremely sorry for the misunderstood of my local time and this webinar. So I'm extremely sorry to all the participants who are waiting for me. So without further delay, I want to start my lecture. And the topic of my lecture is today, can microbes solve civil engineering problems? A perspective of green energy, biocementation, and bioremediation. So basically, I will show some of the like features of microbial activities that can be used for solving some of the civil engineering problems currently we are facing for the sustainable future. So, as Professor Reddy introduced me, I am Azizul Moqsud. I'm Associate Professor in the Department of Civil and Environmental Engineering at Yamaguchi University in Japan. So, I want to take this opportunity to introduce my place where I'm located. Uh, those who are not familiar with Yamaguchi, it is one of the southmost part of main island of Japan, and it is kind of like 190 minutes flight from the capital of Tokyo. And this year, Yamaguchi city has been chosen among the New Year Times 52 places to go in 2024. Like this top three in the list. So I think you are some of are already familiar with this name in Japan. So it has a lot of historical and beautiful sites to watch. So if you come to Yamaguchi, you can find some mixer of tradition and modernization of Japan. And we have like some of the features like 5-storied wooden pagoda and also wooden arch bridge, which are 500 or 400 years ago they built it. Still they are there, and some of the bridges connecting the islands in the ocean. So those are some beautiful places here you can see. But most importantly, Yamaguchi is famous for producing a lot of leaders, national leaders in Japan. In modern Japan, some very famous, I mean, prime ministers are from our places. So it is kind of a place for where leaders are born. And Yamaguchi is one of the oldest university. It is third oldest university in Japan, actually. And we have a lot of history, and right now around 10,000 students are here. And it's we have bachelor, masters, and PhD courses in different faculties, different departments, and divided in 3 campuses actually. So our campus, engineering campus, is in the below, and we can see that, yeah, we have a lot of students so far. We have a lot of alumni all over the world right now. And in this in university, I have my own lab we call Azizul's lab, and it is mainly focusing on the geoenvironmental engineering and green energy. So let's talk about today's lecture and focusing my own research. But before going to that main topic, so I want to state the why I have chosen this type of research topic, and like how bacteria can be active or solve some of the problems. I mean, what is the concept behind? So this is very interesting. So at the beginning of the earth, our earth was like uninhabitable earth. So same as like Mars right now. So no living things can be, I mean, sustained there. But this type of earth has been livable condition because of the microbes. And microbes made the earth as a habitable place at the beginning. So but due to the various human activities like urbanizations and industrializations, cars, everything, and this earth environment has been become very much, I mean, unhealthy conditions, and a lot of environmental pollutions happened. And due to the clean energy shortages, it has a great problem right now. And we also have a lot of like climate change issues and global warming issues, and that consequently causes some of the geo disasters like landslides or some other things. So in short, these problems make the earth unhealthy again. And how can we solve this problem? So there are many methods, many ways to solve this problem. But I was thinking, like, can we solve these problems by using the help of microbes again? So from that concept, today's lecture actually started, and my research is going on. So for example, can we solve the problem of green energy by using the plant microbial fuel cell or microbial fuel cell? And also, uh, can we get the instead of chemical cements, can we use the biocements for the some of the problem solvings? And then can we clean the environment by using the help of microbes with the by bioremediation? So and try to make the healthy world again. So that is the whole concept of my lecture today and my research actually. So that in short, to make the earth healthy again with the help of the microbes. And finally, we can use the results or outcomes of this in the smart city sensors powered by native microbes, or green construction by the native microbes, and also bioremediation by my native microbes. So in short, what I'm doing here, like some of the things is that in tidal area, tidal flood area, and due to the various human activities, it has become polluted. So can we remediate this by using the microbial fuel cell? So we did some like laboratory test and some field test by using this. So I will discuss the detail what is that actually microbial fuel cell in few minutes. And then we also try to generate electricity, which is bioelectricity, to power the sensors and other things by using the plant microbial fuel cell. By using the living plants and with the help of microbes, we can get electricity. And at the same time, we can remediate the contaminated land. So number three is like bioremediation. So using the like friendly bacteria, we can use that and them to clean the geoenvironment. And so we can use this by using the like not only the uh, typical pollution, but also, for example, due to the natural disasters such as tsunami, the vast land area becomes polluted. So it is difficult to clean that land. So in, I mean, traditional way. So we use some special bacteria, or we called it collective microorganisms to clean that. And now we can use those bacteria to bioremediate the landfill ashes. So we'll talk detail later. And number four is like bioelectricity generation by using the organic waste and mixing with soil. So both mixing of waste and soil, we can produce electricity. So at the same time, we can recycle the waste as well. And finally, we also have some people, students who are focusing on biocementation. So that is kind of bioconstruction, and also like for geodisaster mitigation, like liquefaction or landslide mitigation, how can we use this technology? So these are the in short what are doing right now. And as Professor already mentioned, we are also focusing on like bioremediation of microplastic contaminated soil. So right now we are conducting those research. So like why this type of research theme is born, or what is the background of this? It comes basically from the current state of the world and the people's lifestyle. So I think all of you are familiar with this pyramid and world economic pyramid, it is said. And if you look at this, like more than 10% is of the total population of this world, they live less than $2 per day. So this is very sad fact, but this is huge number of people who are like extremely poor conditions they are living. And if you look at them, they have some common lifestyles wherever they live. I mean, whether they live in Asia or in North America or in Africa or anywhere, they have some common characteristics of their living. Number one, like they don't have enough food or good shelter or safe water to drink, and sometimes they don't have enough energy or electricity, and of course they don't have good medical facilities or sanitations, and they cannot take the high quality education, and they don't have good environment. So sometimes they don't have transportation, and they are the people who are the most vulnerable during the natural disaster. So you know uh, these are some common characteristics wherever they live. I mean, whether they live in Asia or in Africa or in, North America, they have this type of characteristics. So if you focus on these points, like who are the responsible to improve their conditions, who are the people those can, change their lifestyle, and most of the things like good, about the good shelter or like safe water to drink or green energy or some good environment or waste management. So the civil engineers have the most responsibility to do that. So yeah, if we want to change the lifestyle of these people, we are the people. I mean, civil engineers have the responsibility. So from that perspective, we focused, okay, can we do something for those people like low cost or less sophisticated technology to change their life? For example, I am focusing here like green energy or like in a lack of electricity. So this is the one famous picture. I think some of you already known it, like world's energy condition or world at night. And if you look at the world from the above, I mean from the space at night, you can find some of the places are very much bright, but unfortunately many places are still dark at night. So all over the world, there are many places still dark, and it means they are not using the electricity at night. And this is the real fact that 1.6 billion people live without electricity right now, all over the world. And many countries in the world can produce electricity half of their demand only. So it's a like huge number, huge. Um, I mean, many people actually live without electricity right now. And now we are talking about more like green energy and everything, which is good for environment or global protect of global warming. But to do that, like 40% of our corn and 12% of soybean crops goes to making into biofuels, and this amount actually would feed all like more than 100 million people. So I think this is just not a sustainable way to the thing could be happen. Like you cannot just waste your food products to make the like gas or gasoline for your cars in the background, that a lot of children are hungry every day. So it could never be sustainable way for the in the future. So this also causes the rises in food prices many places in the world, and about 9 million people die every year of hunger and hunger related diseases. So we have to find out some new solutions. I mean, for that would be a sustainable way. And also people are talking about like green energy more than the safe source of energy due to the some of the nuclear power plants accidents happened some places in the world. So now people are more focusing like how can we get more safe source of energy, not only the green but also the safe. So the keyword is we need energy which is both green and safe. And of course we have some goals, sustainable development goals for the future. So yeah, we must take care of these. So now come to the point, like can microbes solve some of these problems which are like currently facing our world? Number one is waste management problem, and number two is bioenergy related, and number three is bioconstruction, and number four is like bioremediation. So today I am talking, from now on I am talking to focus more on these topics. So let's see about the waste management thing. So we know that recycling is the key component of modern waste, like reduction, recycle, and like reduce, recycle, and reuse. But unfortunately, if you look at the characteristics of the residential waste, both in developing countries and the industrialized parts of the world, a large portion of the total waste is biodegradable waste, and but unfortunately, it is not cared by the to recycle. I mean, even in the for example, in Japan, we just burn the organic waste with the other waste, and due to its low calorific value, I think it's not a good option to burn all the waste together in the incineration plants. So we must think about recycle and like how can we get some energy or some other resources from the organic waste. So can for in that perspective, can we take the help of bacteria? Yes, we can. So for example, we can do some composting. Composting is nothing but um, like microbial conversion of the organic waste, kitchen garbage, or biodegradable municipal waste into the like harmless things, like soil like material. So yes, we can do that. And is the like if we put the in the composting barrel. So actually this barrel was designed by me. So you can really use it for like composting reactor, and it can, I mean, use to help you to reduce the volume and also the temperature control, and ultimately you can get the compost. But can we get both compost and also energy or electricity from the waste? So for that reason, we started the microbial fuel cells. So this is what is microbial fuel cell actually? Microbial fuel cells are electrochemical devices which convert biomass into electricity through the metabolic activity of microorganisms. So in short, when there are some organics, so the microbes they biodegrade it, and at that times electron releases, and if you put the anode and cathode, and the electron will move from anode to cathode, and at the time you can get the electricity. The flow of electron is electricity, and then uh, basically it was used in the waste water treatment areas. So like if you put this technology in the wastewater and then you can get electricity, and at the same time you can speed up the degradation. So from that concept we use it in the like can we use that in by using this microbial fuel cell, so by using kitchen garbage or other biodegradable waste. And after getting the electricity from this waste, can we use the byproduct of electricity as like soil conditioner. So that is the main theme. And actually we designed some microbial fuel cells for this type of purposes. I mean, by using the organic waste or biodegradable waste, and put it some anode and cathode connected some external circuit, and then we try to get some electricity. Yes, we captured the data, and we found that from like one small cell we can get around 600 millivolt electricity, and the peak was reached like in the 21 days. And the power density duration, the with the during the test was also like very good, stable generation. And after the getting the electricity, we checked the whether the byproduct of this electricity can we use it as compost as before, and we checked the NPK value, nitrogen, phosphorus, potassium, the remaining things, and we found that it is quite within the suitable range. I mean, even after the getting the electricity, you can use it as soil conditioner or like organic fertilizer. Then we try to find out with other uh, organic waste, solid waste. So we mixing the this like waste and with organic soil, and make the try to find out, yes, it could be possible, like within the fruit waste we can do it. And even livestock like cow dung and chicken droppings, they can also produce some electricity by this method. And as you know, this part of the Asia is a lot of rice produce. So rice waste is like huge amount every year. So we can also use those rice waste to produce the electricity. And yeah, so not only that, if we mix this waste with the organic soil, so they can also have sustain, quite a long duration, like producing from cells, and amount is also good. So we can use it for USB charger, charging things, and other sensors applications as well. So that is the conclusion. So we can use kitchen garbage, fruit waste, or some other waste which is biodegradable, both for bioelectricity generation, and at the same time we can use it for like soil conditioner. The byproduct of the electricity we can use as soil conditioners, and it could be a sustainable, renewable green energy from the organic waste. And yes, so one problem, the waste management can be solved, and also the other problem, the green energy. So which both green and safe energy, safe source of energy, can be achieved with the help of microbes through the microbial fuel cell. So that is the thing. So in this first part, I am addressing the three major problems. One is like environmental and health problems in urban areas due to unmanaged waste. So one of the sources of environmental pollutions is waste through the waste here and there, like illegal dumpings and not caring the geoenvironment. But if we use this technology, microbial fuel cell technology, then it could be solved. And then as the we can produce the soil conditioner, so if we use those things, then it will change the problem of organic matter depletion in the rural areas as well. But most important thing is that, like as I said, 1.6 billion people live without electricity, so we can give some light of hope to all of them. Then I just bring thinking that can we use this with some other applications, and from plant microbial fuel cell, look at this. this mechanism. So when the green leaves get the sunlight due to the photosynthesis, they produce the carbohydrate in their green leaves, and naturally there's 60% of this carbohydrate they releases through in the root area, and the geobacteria who lives near the roots, they eat it or break it, and at that time 24 electrons release. And as mentioned, if we put the anode and cathode, you can capture this electron. So that is the basic mechanism of plant microbial fuel cell to get electricity. So in the left hand side, actually this is the general normal way of producing the carbohydrates in the leaves, green leaves, due to the photosynthesis. And we just place the anode and cathode to catch that electron, which are naturally occur. So it will not harm the trees or plants, but at the same time we can get the electricity. So the main thing is that you can get both, like harvest the food and at the same time harvest the electricity. And this could be like clean sources of energy because no combustion of gas, no air pollutions happened in this method, and it is a sustainable way, so no plant harvesting needed. And as I mentioned to before that, nowadays for green energy, people use a lot of food products like corn and soybean to break down and destroy and get the fuel. But in this method, you do not need to destroy the food. You can get both food and at the same time get both energy. And basically it kind of uh, renewable energy, because this is in this method only the solar energy is used by the plants, and the microbes are working in naturally in the ground or land. So we tried to find out whether it is possible, really possible, to get electricity and at the same time food with this method. So we tried with rice plants or paddy plants. As you've seen, a lot of countries in all over the world, their main food is rice, and a lot of rice is producing everywhere in this area. So can we get electricity from this during this rice production? So that was the main motto of this research. So the thing is that can we get both food, rice, and both electricity? So at first we tried some simple experiment. So we use some carbon fiber as electrode materials, and then we use like rice, one bucket of rice with those a microbial fuel cell, and another one without rice. So left hand side it is before starting the experiment, just it, and the right hand side after the experiment. So if you look carefully, some rice are grown here, and at the same time you can see that we can also get the electricity. So here is the result for that. So when there are paddy plant, we get this amount of electricity, or without paddy plant, like half of that. So this proves that plant microbial fuel cell can work. So if there are plants, you can get more electricity because of the mechanism I said before. The photosynthesis, carbohydrate happen and grow, and the release of carbohydrates through the root zone, and the bacteria eat or break that carbohydrates and release the electron and catch the electron. And then we try to make it more like a little bit mixing with compost, which we did in our previous experiment by organic waste. And then in we found that in if we mix like 1% or 3% of compost, then the plants grow more, and they are like bigger compared to other plants. It means that plants get more food from the soil, so they get more organic. And after some days, rice grows as well. So we can get both rice, and also we can both get the voltage, so or electricity. So rice plants can generate electricity during the experiment, and which is significant amount, I will say. And we check that, like, the growth of the plant is hampered or not. So it did not hamper the growth. I mean, after placing the you know, car carbon fiber, it was okay, because um, the carbon fiber and the root are attached. I will show you later. So this is called polarization curve, and this is the relation between the voltage, current, and the power density. And we found that our cell works like ideal cell. This type of shape is called good for the any battery or cell design. And then after the experiment, we tried to find out what happened actually in the root area. So we take out the root and then wash it, and we found that the carbon fiber and the root are attached so closely that it created the like bonding, and or the way of transferring the electron which are released. So the white one is the root, and the like other side smaller one is the carbon fiber. So they are attached so nicely that the electron transfer easily. So that was the way why reason why so much electricity was generated. Then we try it in the field test, real rice field. So in our local area, we did it, and we found that in the local, in the rice field or the field test, it is working. And then we calculate, like, if we make the in Japan, like all the rice field to make into uh, these plant microbial fuel cells, then we can basically power the 3.76 million households for all their needs. But in some of the places in the world, they produce the rice 2 times or 3 times a year. So in those area, it could be like amazing source of electricity as well. So in conclusions, bioenergy can be generated from the rice field, and you can get both food and also green energy from these plant microbial fuel cells. And carbon fiber is a good electrode for plant microbial fuel cell, and of course it can um, like give some light of hope to the people who those people who are not living in electricity right now. So in this part, we mainly focused on 5 major problems. Number one is geoenvironmental and health problem due to unmanaged waste. So you can make the recycle your waste and make it like compost and use it in your plant microbial fuel cell to get more electricity. And that will cause the organic matter depletions problem. And of course, you can get both food and both energy. So it will like work on the world food crisis. And of course, it will be green source of electricity. So no problem of global warming. But most importantly, as I said, like 25% people of the world are living without electricity. So you can give just light of hope to those people. Then move to the third part of this lectures, bioconstruction. So can we use the microbes in our civil engineering construction or protection? So basically I will focus on native bacteria. Native bacteria means like those bacteria who live in the places where you're trying to working in the, especially in the soil environment. So this is one another famous picture. I think this is from NASA. So they called it like landslide potential. So all over the world, there are some problems of landslide or some kind of geo disasters of due to the rainfall or earthquake and everything. So it is not the local problem or local issue actually. So some places are very severe in landslide potentials, and some are moderate or slight, but whatever it is, that this is the problem. Especially in Japan, the southern part of Japan, they have a lot of places which are like very much prone to the landslide. And especially where Yamaguchi, where I'm living, it has potential of landslide during the heavy rainfall. And in recent years, due to the climate change and everything, so rainfall intensity is very much higher, sometimes causes the landslide in frequent pattern. So what is the problem of this actually? So to protect the landslide and other geo disasters, right now civil engineers, we are using the chemical cement to land improvement or for other purposes like make concrete or everything. But the problem is that almost 7 to 8% of the total carbon dioxide gas emissions, so like greenhouse gases emissions, are from the cement production, so chemical cement production. So it is directly, I mean, related to the global warming phenomena. I mean, so this current approach to protect the soil or the slope is not environment friendly. So can we use the bacteria or native bacteria to overcome this problem? So, I mean, without using the chemical cement, can we make the soil with biocemented with the bacteria? Or can bacteria help to solve this problem again? So this is the main background. And this is nothing new actually. So we can find that many places in the world, engineering in the nature is going on, and we can learn many things from the nature. So this is one very famous slide, I think, prepared by Professor uh, and UC Davis, Professor Dijong. So he showed that we can learn many things from the nature actually, so for in geotechnical engineering. And from that perspective, biocementation is one of them. So biocementation is nothing but we can make the soil with the hard by using the bacteria. So this is the objective, like can we use this method to protect the natural slope? So those who are not familiar with the biocementation, so if you go to the near the sea beach area, so you can find some like sandy rock or something like rock-like materials or hard sand. So those are nothing but biocemented by the bacteria. So what is that actually? So the bacteria can produce calcium carbonate, and which can attach the soil particles each other. Okay, so that is the main mechanism behind this. So soil particles can be attached each other with the help of microbes or metabolic activities of the microbes. So that is the called biocementation. So we did some direct shear test after making the biocemented soil, and we checked it in the like scanning electron microscopes, and we found that calcium carbonate produced on the surface of the particles, and that, and also the is I mean strength increased after using the biocementation. So soil strength can be increased with the biocementation. Both angle of resistance and cohesion, they are also increased in biocemented soil. And so this method can be used for protecting the slope or erosions in the slope area due to the rainfall as well. So we checked it after like in artificial rainfall experiment by making the slope harden with the microbes which are, I mean, native in our area. And then we can found that it is possible to make the soil hardened with our strength increased with this microbe. So biocementation is possible and we can do that. And we also check the like X-ray CT scan of this biocemented soil at like 10 centimeter, because sometimes we place the nutrients and nutrients from the surface. So the uniform distribution is always a question, like whether they are uniformly distributed or not. But we check it through the X-ray CT scan, and found that yes, the calcium carbon, the white dots, they are throughout the depth. So it is confirmed at least 10 centimeter you can do it without any problem. So yeah, in this part, so as I mentioned, biocementation can protect the land erosions or landslide disasters, and some it is kind of like protect the global warming phenomena, because you do not need to use the chemical cement. So that means that it will reduce the CO2 emissions. In that perspective, we can use the help of bacteria to solve the problems. And final part is bioremediation. So in this part, so I will mainly focus on bioremediation and like gas analysis of landfill waste by using collective microorganisms. So this bioremediation is not like a traditional bioremediation. So we are mainly focusing on the salinity of the soils, because salinity of the soil is one of the very serious geoenvironmental problems right now. It's not like local problem, but it's a global problem. So in the high saline soil, plants cannot grow. So ultimately they dry and no crops can be grown. So it is very difficult, extremely difficult to clean those type of contaminated soil by, and every year the area of um, this type of saline soil is increasing all over the world, and that is the main causes of desertification. So it's a serious problem actually. And um, due to the like climate change and the global warming, the sea level rises. So new places are now problem affected by the seawater intrusion, and like salinity is becoming more serious problem day by day. So especially due to the natural disasters like earthquake and tsunami in Japan in 2011, and also in this year some tsunami happens, and those causes some seawater contamination in the vast agricultural land as well. And traditional method to leach or wash is very much extremely difficult, so because the amount of land and lack of fresh waters to do that. So we are trying to make some like bioremediation by using some lab grown or friendly bacteria to apply with compost. So yeah, desertification is a very vulnerable condition all over the world, and one of the causes is the high saline soil. So we can clean that soil as well. We can use this technology to the landfill ash bioremediation. So in Japan, lot of industrial waste and other waste, as I mentioned, they are burnt in the incineration plants. So after during the burning, they use some chemicals to mix that to burn properly, and that causes the high salinity. So it is difficult after that, like how to remove that salinity. So we try to using our bioremediation technology, and also you use some recycled waste glass, we called it foamed waste glass, mixing with different organic waste, and then did bioremediation. And we also prepared some collective microorganisms in the laboratory for this bioremediation. And also we check the gas emissions during those bioremediation. So this is the picture of our like collective microorganisms which we are using in our experiment. And then what are doing, we use some foamed waste glass or recycled waste glass which is like manufactured and I mean from the waste glasses and used as other geotechnical materials widely used in Japan. So we try to use it in our geoenvironmental perspective, like because it has pore spaces, and we thought that it could be the good places for bacteria to live there. So, and we made some landfill simulator like this, and we use the both bacteria and other I mean foremost glass mixes, and then we check it the gas emissions, and we also check the electrical conductivity, and we found that mixing with other kitchen garbage or rice bran, the salinity reduced significantly compared to the blank, and pH is in a good range. Like geoenvironmental condition point of view, it is very good. And we check how the mechanism happens, because it's not common to remove the salinity from the by using bioremediation. So we checked it by gas chromatography during the test, and we found that some of the chloride, they becomes like compound and become gas from the saline soil. So that is the mechanism actually. So the bioremediation of extreme bad soil or landfill ash can be done with the help of collective microorganisms. And so again, the microbes can help to solve the problem, which is proved in a different way, like both natural disasters affected soil, or for example, like landfill ash, those can be cleaned by or bioremediated with the help of these microbes. So here we just addressing the three major problems. So like high saline soil, so we can clean it. That salinity could be removal, and then organic matter depletion. So yeah, using the mixing the compost and put it in the soil, that will increase the nutrition condition of the soil. And due to the like salinity, food production is reducing, so we can solve that food shortage problem. So this is the last. So my question was like, can microbes solve the civil engineering problems? And at the end of this presentation, I think all of you are got this answer. Yes, some of the problems can be solved. Civil engineering problems can be solved with the help of the microbes. And especially we focused on waste management, bioenergy, bioconstruction, and bioremediation. So I think, yes, we can solve these problems. So thank you very much for your attention, and I'm very much sorry again for my misunderstanding of the timing of the starting of this lecture.
Yeah, no problem. Yeah, thank you so much for that very interesting presentation.